Hello viewers, today I'm going to work with you on problem solving in the mole concept. Our problems will include relative molecular mass, molar mass, empirical and molecular formulas. It is therefore imperative for you to first carefully watch my video on the mole concept part 1, lectures only, using the following link. I'll be back in a second. Welcome back. Question 1a. Calculate the molar mass of the Morse salt. B. Calculate the number of moles in 20 grams of the Morse salt. Hence or otherwise, calculate the number of molecules of this salt present in 20 grams of it. Let's begin with the A part of question 1. Calculate the molar mass of the Morse salt. The molecular formula of the Morse salt is Now, what are we looking for? We are looking for the molar mass, which is the sum of the relative atomic masses in 1 mole of this compound. We have 2 moles of ammonium in 1 mole of this compound, so we write 14, the relative atomic mass of nitrogen, and we have 4 atoms of hydrogen. The relative atomic mass was given to be 1. So 1 times 4 is 4. So we have plus 4 plus iron is giving us 56 plus, but we have 2 sulfate radicals in this compound. So we write 2 into 32 plus 64 plus 6 times 18 grams, because we have 6 molecules of water. If you use your calculator well, you are going to sum this up to give 392 grams per mole. That's all for the A part of the question. Is the A part of this question, question 1A. Now let's go to question 1B. 1B says, calculate the number of moles in 20 grams of the Morse salt. Hence or otherwise, calculate the number of molecules of this salt present in 20 grams of it. So we have 2 parts in this question. First, we have to calculate the number of moles, followed by the number of molecules of the Morse salt. Let's begin with the first part, the number of moles. By definition, the number of moles, small n, equal to given mass over molar mass. I told you in the first video that I will be using MR to stand for the molar mass and the relative molecular mass. I've just started using it. So the given mass here is 20 grams and the molar mass is 392. So we can simply substitute 20 grams divided by 392 grams per mole. This will give us 0.05 mole. The second part of the equation says we should calculate the number of molecules of this salt. The number of molecules is given by X equal to small n, the number of moles, times the Avogadro's constant. So this is equal to 0.05 times 6.02 times 10 to the power 23. And this gives us 3.07 times 10 to the power 22 molecules. So this is our answer. Question 2. What is the percentage of carbon in glucose? Whose formula is C6H12O6. Solution. Analysis. One molecule of glucose contains 6 carbon atoms. AR for carbon equal to 12 and MR for glucose is equal to 180. Now, in the first video, we learned that percentage composition is equal to X times AR divided by MR times 100. This means that percentage composition of carbon should be equal to X here is the number of atoms of carbon in one molecule of glucose. So we have 6 carbon atoms times the relative atomic mass of carbon 12 divided by the relative molecular mass of glucose 180 times 100. This gives us 40%. Question 3. The analysis of a halogenal compound gave 45.9% carbon, 8.9% hydrogen, and 45.2% chlorine. Small Roman 1. Calculate the empirical formula of the compound. Small Roman 2. What is the molecular formula of the compound, given that the relative molecular mass is 78.5? Small Roman 3. What conclusion can you draw from small Roman 1 and small Roman 2? Solution. Small Roman 1. To solve this problem, we are going to follow these steps. Write down the elements that are found in that compound. So we have elements. Carbon, hydrogen, chlorine. Next, we write the percentage composition by mass. Percentage composition by mass. Carbon is 45.9. Hydrogen is 8.9. And chlorine is 45.2. Next, we calculate the number of moles of each element. So, use your calculator to solve for the mole of each element. This will get 3.825. And here we get 8.9. And finally, chlorine, we have 1.2732 moles. The next step is we divide by the smallest number of moles. In effect, we are calculating the mole ratio. The smallest among them is 1.2732. So we divide by that. So here we have 3.825 divided by 1.2732. And here we have 8.9 divided by 1.2732. And finally we divide this 1.2732 divided by itself, 1.2732. Here we have 3. Here we have 7. And finally, here we have 1. Therefore, empirical formula, or abbreviated EF, equal to C3H7 Cl1. So you don't need to write 1. So this is the empirical formula of that halogenal compound. Now, in Roman 2, it says that what is the molecular formula of the compound, given that the relative molecular mass is 78.5. So let's work it out. Small Roman 2, we have C3H7Cl multiplied by this factor N is equal to the molecular mass, or the relative molecular mass of that compound. When you sum all the relative atomic masses in this empirical formula, you will have the molecular mass of the halogenal compound that is given here. So let's start summing right away. We have 3 times 12, 36, n plus 7 times 1 times n, we have 7n. 1 times 35.5 times n, we have 35.5 n. All this should give us 78.5. If you compute this correctly, you will have 78.5 n. So we have 78.5 n equal to 78.5. This means that our n is equal to 1. N is equal to 1. Therefore, our molecular formula, which I will abbreviate MF, is equal to C3H7Cl. Small Roman 3 says, what conclusion can you draw from Small Roman 1 and Small Roman 2? Now, if we look at what we have done in Small Roman 1, we have seen that Small Roman 1 were to calculate the empirical formula, and we calculated it to be C3H7Cl. And in Small Roman 2, we were to calculate the molecular formula, and we calculated that to be C3H7Cl. So we can conclude that the empirical formula is equal to the molecular formula. We write the empirical formula is equal the molecular formula. That is all for this question. Okay, viewers, I'll end here for today. In the next class, I'm going to start with the mole concept, part 2b, problem solving only. But I'll leave you with this homework. Take it down. 1.0 grams of an organic compound, capital A, containing carbon and hydrogen only, on analysis gave 0.86 grams of carbon and 0.14 grams of hydrogen. On treating capital A with acidified water, a compound capital B of molecular mass 74 was obtained. The reaction of capital B with concentrated sulfuric acid at 170 degrees Celsius gave compound A. Small roman 1. Calculate the empirical formula of capital A, small roman 2. From the reaction that produces B, deduce the molecular mass of A, small roman 3. Deduce the molecular formula of capital A, and small roman 4. What conclusion can you draw from small roman 1 and small roman 2? Make sure you do the homework before the next class. I will do the correction in part 2B of this same topic. Make sure you like and subscribe to my channel so that you will receive notification when I upload new videos. Thanks for your keen attention. Thanks for watching.